electric flux due to a very long uniform linear charged wire. So I'm considering here a uniformly linear charged wire. So this is the linear charge density of the wire. That means the charge per unit length or charge per centimeter, charge per meter is constant throughout, right? Let the wire be along the x-axis. So this is here the end of the charged wire where we have to find the electric flux through a ring of radius r, right? So what I will do here, I will consider here a ring element, suppose at a distance of y from the center of the ring or from the end of the wire, which is perpendicular to the wire, or we can say that this is along the axis of the ring, okay? Now, the ring element has the thickness of dy, right? Now, first of all, let's see what is the electric field at this point at a distance of y from the end of the wire or from the center of the ring, right? Now, if E is the electric field, then the electric field has two components, one along the x-axis and second along the y-axis. Since Ex is parallel to the area vector of the ring element, that is ds, so the dot product of Ex and ds will be simply Ex ds, whereas Ey, it is along the plane of the ring, or it is perpendicular to the area vector of the ring element. So Ey is perpendicular to ds vector. So we can get Ey dy is equal to 0. Ey dot dy is equal to 0, right? Now, first of all, let's calculate what is the area of the ring element. Since the thickness of the ring element is dy and it is radius is equal to y, so the ds is equal to 2 pi y, that is the circumference of this, times the thickness of this, so it is 2 pi y dy, right? Now, E is equal to Exi plus Eyj in terms of rectangular components, and Ex is given by lambda divided by 4 pi epsilon naught y, so it is I cap, plus lambda divided by 4 pi epsilon naught y, then it is root 2 j cap. Since we know that only Ex will contribute to the flux because only Ex is along the area vector, whereas Ey is perpendicular to the area vector. So the small flux through the ring element of thickness dx can be calculated by the basic formula d phi E is equal to Ex ds. So that comes out to be lambda divided by 4 pi epsilon naught y. So then it is ds, it is 2 pi y dy, right? So this pi and pi cancels, 2 1s are 2 2s are, so it is lambda divided by 2 epsilon naught, so it is dy. This gives us the total flux is equal to the integral of these small differential fluxes from 0 to the radius of the ring. So that is 0 to r, lambda divided by 2 epsilon naught dy, that comes out to be lambda divided by 2 epsilon naught, then integration of dy from 0 to r. So when we integrate this dy from 0 to r, we get simply it is r. So therefore the flux through the ring due to this linear charge distribution is lambda divided by 2, it is r divided by epsilon naught. So this is how we calculate the electric flux due to a linear charge distribution that passes through the center of the ring, which is perpendicular to